Welcome to Study Time, a televised home learning program produced by Rwanda Basic Education Board.
Dear students, welcome back once again to this session of 30 minutes. I welcome most specifically Senior 5 class, that is chemistry, and we are looking at the Unit 5, alcohols and ethers. Actually, we finished that one, so we'll be looking at some questions together. So I invite you to be ready, write down some important information. We are just writing, so we'll be doing the questions and answer. So it is question and answer approach. So let's see how we can be able to answer the questions together. Please, you are welcome to this session. So without wasting a lot of time, let's go straight to question number 1. Give the reagents and conditions you would use to carry out the following conversions. One or more steps may be involved in the conversions. So there is no direct. It is not necessary that you may have only one direct method. Part A, you need to move from ethanol to ethyl ethanoate. That is from an alcohol to an ester. So if you remember the reactions of the alcohol, the preparation methods, all these helps you to remember how we can move from ethanol to ethyl alcohol. So number 1, part A, we are moving from ethanol to ethyl ethanoate. Ethyl ethanoate. Ethyl ethanoate. So we're moving from CH3, CH2OH to ethyl ethanoate. Ethyl ethanoate is like this, COO or CH2, CH3. So this is ethyl ethanoate. So one condition using ethanol as the only organic starting material. So we are not supposed to react ethanol with another substance. So we need to use ethanol as the only organic starting material. So what do we do there? This is what we're supposed to do. So what we are doing, because we are starting with only ethanol, so what we will do, we'll have to first oxidize ethanol. So we oxidize ethanol with potassium permanganate, or we can use potassium dichromate. All these ones take place. So when we oxidize, these are strong oxidizing agents. So they will produce a carboxylic acid. Alcohols are oxidized to carboxylic acid. So we'll go directly to carboxylic acid. So after getting that carboxylic acid, so the product will also react it with ethanol. So we'll get the carboxylic acid, that is ethanoic acid or ethanoic acid. Then we add ethanol, because we are supposed to get, remember, this reaction is reversible and takes place in presence of concentrated sulfuric acid. We need to indicate the reagents and conditions. Give the reagents and conditions for every step that is that you take at 100 degrees Celsius. So this one will give us a carboxylic acid, and an alcohol gives us so that is the organic product that is formed. So this is part A, which is complete. Part B, we have to move from ethanol to 1,2-dibromoethane. Move from ethanol, so you have ethanol, part B. Nanjire cyangwa mutegereze. B, so when we move to the part B, it is saying ethanol to 1,2-dibromoethane. So how do we move from ethanol? This is ethanol, that is the starting material, and we move to 1,2-dibromoethane. 1,2-dibromoethane, that is CH2 bromine. So how do we do that? How do we carry out this reaction? So what we do, we are going to dehydrate this alcohol. So we're going to dehydrate the alcohol. So we'll get ethanol in presence of concentrated sulfuric acid and at 170 degrees Celsius. You remember when we talked about these are reactions of alcohols that we are looking at. So this will give us ethene and water. So what do we do next? Remember we said these are the conditions and the reagent. So the reagent here is concentrated sulfuric acid, that is a dehydrating agent. The condition is 170, specific 170. So after getting the alkene, which is ethene, then we'll add bromine. This reaction takes place at room temperature and in presence of carbon tetrachloride as a solvent. So this one will give us the product that we need. CH2 bromine, 1,2-dibromoethane. This is 1,2-dibromoethane. Let's go to number C. Number C, ethene to ethanoic acid. So we are moving from ethene, this is ethene, and you move to ethanoic acid. This is ethanoic acid. How do we move from there? Which reagent do we use? Do we have any one substance, one reagent that we can add to this to get this? No. So this is what we're supposed to do. So you have ethene, an alkene, you add water in presence of an acid, can be concentrated sulfuric acid. So in presence of an acid, you are going to get an alcohol. This is one of the preparation methods on large scale. Hydration of alkenes, you will produce an alcohol. So when you get the alcohol, what are you going to do with the alcohol? Oxidize the alcohol. So you are getting ethanol, oxidize it completely using strong oxidizing agents. So we are saying we are using potassium permanganate. So the manganate ions provided by the potassium permanganate, or you are using the potassium dichromate, or the dichromate ions from the potassium dichromate in presence of acid and warm if necessary. But the reaction cannot even take place at room temperature. So this one will give us the carboxylic acid that is required. Good. When we go to part E, this was part E, A, B, C, D. So we have part D before we go to part E. Part D, ethanol to propanenitrile. This is a nitrile. So we could have even looked at this when we looked at the reactions of the carboxylic acids. So now, or even alkyl halides. So these families are connected, very strongly connected. So you cannot leave out one family. So when you leave out one family, you get problems with another one. The homologous series. So we're moving from ethanol which is CH3, CH2OH, to propane nitride, CH3, C2, CN. Or you can even put, this one has a triple bond. This is the propane nitride. So how do we move from there? How do we move to there? So what we can do here, we are going, in the first step, we are going to substitute this one. So we'll say CH2 plus, we can even add concentrated hydrochloric acid. When we add concentrated hydrochloric acid in presence or heat, so this one will produce CH3, CH2 with chlorine, an alkyl halide, and water. So getting an alkyl halide, what do we do with the alkyl halide? This is C with small l, that is chlorine, alkyl halide. So after getting the alkyl halide, that is CH3, CH2 chlorine, what do we do is this? We'll add potassium cyanide. When you add potassium cyanide, you see there is an increase in the number of carbon atoms. From ethanol with 2 carbon atoms to propane nitride. So the potassium cyanide increases. This is nucleophilic substitution. So in presence of an acid at around 20 degrees Celsius, that is slightly lower than the room temperature, this one gives us, because I said it is N, then plus potassium chloride. So the acid is a catalyst. This is propane nitride. E, we are going to part E. We have bromoethane to ethoxyethane. Bromoethane to ethoxyethane. So this is step. Bromoethane, this is bromoethane to 1 bromoethane. We are moving to ethoxyethane. This is an ether. So how do we move from bromoethane to ethoxyethane? You see, the number of carbons have increased. So what do we do is this? We'll have to first convert this one into an alcohol. How do we convert it into an alcohol? This is a bromoalkane. So we have CH3, CH2, OH, bromine. We have bromine. We'll add sodium hydroxide, aqueous sodium hydroxide, and you remember this reaction takes place in form of heat or under reflux, or we use the word reflux interchangeably, though it's not the same, but those words are used interchangeably. Then we will get the alcohol, CH3, CH2, OH, plus the sodium bromide. So after getting the alcohol, what do we do with the alcohol? OH. Now the reactions of the alcohols. How the alcohols react to form ethers. So we react this with concentrated sulfuric acid. Remember the reactions of alcohols with concentrated sulfuric acid. We talked about 3 categories. So this is one of them. At 140 degrees Celsius, 140 degrees, and you remember we said the alcohol has to be excess. So 140 degrees Celsius, this will give us C2 or CH2, CH3 plus water. So this is what we are looking for, and that is what gives us that answer. So this is how, these are some of the methods. Remember, there could be some other methods, not necessarily this. So you can as well use some other methods to prepare those. So don't stick to this. Remember, you can still use some other methods to produce these reactions as well. So let's go straight to number 2. 3 alcohols, A, B, and C, of molecular formula C4H10O were separately heated with acidified potassium dichromate. That's, remember, it's a strong oxidizing agent. Alcohol C did not undergo any change, while A and B did. Alcohol A produced compound D, which reacted further to form compound E. Alcohol B reacted to form compound F. Compound F did not react with Fehring solution, but reacted with 2,4-dinitrophenyl hydrazine. Suggest structures. So we need to suggest some of the structures of these compounds. Number 2, ABC. So you need to read the question second time. ABC, molecular formula C4H10O, were separately heated with concentrate with the acidified potassium dichromate. Alcohol C did not undergo any further change. What does that mean? That alcohol C is a tertiary alcohol. It does not go under further, because that is an oxidation reaction. So it does not undergo further oxidation. That is, further changes means there is no further oxidation. So C must be a tertiary alcohol. So that means, let's first write the isomers of these compounds, because they are all alcohols, A, B, C. And they are alcohols, so that means they are isomers. CH3, CH2, CH2, 1, 2, 3, 4. OH, that is first isomer. CH3, CH2, CH with OH, CH3, 1, 2, 3, 4. That's another one. CH3, CH2, CH. So we may have CH3, CH2, OH. So we need another one. There must be another one. So another one is CH3, 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 OH. 1, 2, 3, 4. So these are isomers. So we have already identified that C must be a tertiary. So C is this one. That is automatic. Then they say alcohol C did not undergo any further change, while A and B did. So the A and B have to come from here. Alcohol A produced compound D, which reacted further to form compound E. Alcohol B reacted to form compound F. F did not react with Fehring solution. That is very important. That means if F does not react with Fehring solution, what does it mean? It means F is a ketone. F must be a ketone. And that ketone comes from, ketones are derived from secondary alcohol. This is the one that will produce the ketone. So F, if we look at F, so I can start with F. F must be coming from, this is CH2, so I would say COCH3. So this is F automatically. This F, how did we get F? Compound alcohol B reacted to form F, so that this is the B. This is B. That is how, because secondary alcohol, they are oxidized to F, F which is a ketone, and ketones do not react with fairing solution, but they react with Brady's reagent, which is 2,4-dinitrophenylhydrazine. So we are remaining with alcohol C now, alcohol A produced D, which reacted further to form compound E. So that means we may have compound alcohol A produced D. If we have this one, it will form an aldehyde, and an aldehyde will change into a carboxylic acid. This is now, this one will be alcohol A produced D, which reacted further to form E. So alcohol A produced D. So if we say this is alcohol A, it reacted further to form E, produced D, which is an aldehyde. So that D, we don't have it. So this is the D. CH3, CH2, CH2, C1, 2, 3, 4, CHO. This is D. And that means this is A. Which one are we left with? E. So E must be a carboxylic acid, because this one reacted further to produce the carboxylic acid. That means it is oxidized further to a carboxylic acid. So it will be CH3, CH2, CH2, COOH. And this one will be E. So we have A, we have B, we have C, we have D, we have E, and then we have F. That's how we can be able to identify these compounds. You need to reread the question and understand. But all these ones are only on oxidation reaction. Interpret the question. Let's continue and look at the next question, number 3. The scheme below shows the sequence in the synthesis of M. You see where M is located. This is where M is. From ethanol, starting from ethanol. This is ethanol, to that one, amine, and so on. What reagents and conditions are used for step 1? So we need to look at step 1. This is part A of the question, Roman 1. Step 1, you are moving from an alcohol to alkyl halide. What reagents and conditions? Step 1, reagents. And then conditions. So the reagents that we are using here is concentrated hydrochloric acid. Concentrated hydrochloric acid. What is the condition? That is heat. Step number 2, this is Roman 1. Step number 2, you are moving from alkyl halide to amine. That is, you remember these reactions of alkyl halides. So this is the reagent. You use ammonia solution. Ammonia solution in alcohol. The condition here, so this is ammonia, the alcohol will be the condition. So because the alcohol is used as a solvent, then we go to step number 3. We are actually asked step number 3, not step number 2. Step number 3, this is what is asked in the question. So this is Roman 2. That one was not asked, or maybe it will be asked later. Step number 3, you are moving from this compound to this. So what is this compound here? This must be an aldehyde. So you are moving from alcohol to an aldehyde. So that is, what is the reagent? So the reagent there will be, oxidizing agents. They don't need to be strong because if you use a strong oxidizing agent, you will go to the carboxylic acid. So here you'll need manganese 4 oxide, and the condition here, still you need the concentrated sulfuric acid. This is a weak oxidizing agent. So when you go to step number 4, here from this is a carboxylic acid to acid halide. So step number 4, that is phosphorus chloride or sulfur dichloride oxide. And you need to heat. These are reagents, and this is those 2 compounds. Then name the type of reactions that occur in step number 2. Step number 2, the type of reaction is nucleophilic substitution. This is nucleophilic substitution. Nucleophilic substitution. Step number 4, what is this step here? That is oxidation. You have step number 4, that is an oxidation reaction. Step number 4, that is oxidation. But this one has to be mild oxidation because it is not strong. Step number 6 involves the reaction between that is acid halide and ammonia to form M. Name the type of reaction that forms M. That is nucleophilic substitution even again. That is C, still nucleophilic substitution. Nucleophilic substitution. The type that draw the full structure of M. So M is reacted, so you have CH3, CH, we have, this has to be an amide, CH3, CH, then you have NH, then CH2, CH3. So this is the structure, the full structure of compound M. This is compound M, formed through nucleophilic substitution. That is a secondary amide. Probably I'll have to leave you with this question. Please capture that question and then try the question. The next lesson will be actually continuing, and we'll be looking at the same question and look at the answer that you have got. Thank you so much for being with me in this 30-minute session. I hope you have probably got something that we were discussing together. You have been reminded, or there is something that you had forgotten. I thank you so much. See you next time in the next lesson. I hope you'll be there. Bye-bye.